So, welcome to all. So, this will be the third lecture, seventh lecture in this series. As I told already that uh, due to short span of time, I will the things I will try to cover in Python as well as in Matlab also, because in Matlab all these things are inbuilt. You can call the library function and just in a single line you can execute the instruction. Okay, so in the last lecture we learned the regression and the polynomial fitting. So these things we will try to learn in Matlab today. Okay, so first we will work with the earlier file. So here is a single variable, so single input and single output. Okay. So so here we will take the input and out one. Okay, so better to include this property. You copy and you change the working folder. Okay, now you see all the files. So we will be working with two files, this one and this one. So now we're defining a variable called d, and the command for reading the data from Excel file is xls read. Then you simply type the file name. It is test dot extension is excel sx. Okay, so now all the data, it has come inside the variable called d. So now we will work, the x is the input, which is all row and first column. Okay, and the should be y should be uh, just 1 minute. It should be all row and third column. So this is the data I want to read from that particular Excel file. Okay, now I want to fit it. So this you can check for, because we will use the function called polyfit. What is that, if you want to know? So it is, you type simple help, then polyfit. If you type, so it will give the details about the polyfit. Okay, so here you can see this is the x value, this is the y value, and this is the order of the equation. If it is a linear, first order; quadratic, second order; cubic equation, whatever maybe you can give, but it will always optimize it. Say in case of actual, the best fitting will be as a linear. So if you give the higher order polynomial estimation also, so it will consider the first order only. Okay, so now I am defining one polynomial equation p, and it is polyfit polyfit my x and my y, and let us I am giving a cubic equation. Okay, so now it is estimated, it is already estimated. Now I want to check how the actual data and how it is best fitted. Okay, so for that uh, I am uh, defining another or you can take directly the value x. Okay, and your new y you can denote as y1. So this is uh, poly for executing the value using that particular model whatever we have fitted right now. The command is polyval. Okay, then you give the whatever the model we estimated, then x. Okay, it is already done. Let us plot and see. So plot is x comma y, that is the original data uh, using which we fit the model, and now we will plot versus the original data and the estimated. This one we will plot it. Now you see the blue color curve. The blue color curve is the actual curve, and based on the optimization, means after estimating, that brown color curve is the best fitted curve for this. So using this command, very easily you can uh, do the regression or the curve fitting whatever already we learned in Python. Okay, now let us take the second example, mean second table. So here we will take some we will take two variable only. You can work with here four variable, but I will take two variables and the output y. So this is x, this is x1, x2 and y. You can try with x3, x4 also. Okay, so this is the first, second, third, fourth, fifth. So we'll take first, second and fifth column. So better I'll write in script. So here the data is equal to xls. You see already it is coming xls read. Now the file name is test1. See it is already come. Now my x1 is equal to the first column. So it's a all row first column. Okay, and my x2 will be d1 first all row second column. Okay, and my y will be all row fifth column. So I am taking only two data. You can try the same with three or four data also, absolutely no problem. Now you can see in the Matlab workspace, once I will run it, it is asking to save. Okay, let us save. So after running, you see x1 this many value, y1 this many value, x2 this many value, and y this many values. Okay, now here what I will do, I will here also I will try to fit one linear regression model. Okay, so the command is fit linear model. So you can give some p or p1, that is fit linear model, and before that you have to define the input vector. So the x is equal to because there are two variable x1 and x2. Okay, now if I run, you see the dimension of x is 6 cross 2 and y also, here 6 values will be there. Okay, so now my model will be is equal to fit lm linear model my x comma y. Okay, if I run this, let us run. You see, now my equation is here. You see these values. My equation is y is equal to, let us note down, this is my y is equal to 6.094 plus 3.7819 x1 minus 1.3993 x2. That is the equation. So if you take 4, 5, 6, whatever the value, here 4 values, accordingly it will come like this. Okay, you can try with that. So now what I am going to do, I will now these are all, this is not, I am deleting this, and here I will write my new equation y1 is equal to 6.094 plus 3.7819 sorry 3.7819 into x1 minus 1.3993 1.3993 into x2, sorry x2. Okay, so this is my equation. Now let us plot, because it is a three-dimensional. Why I take three variables? Because to visualize. But in case of more than three, it is difficult to conceptualize. So I will use plot 3. So that is x1 comma x2 comma y comma x1 comma x2 comma y1. So this I want to run. Now you see this this is best fitted here. It is a 3D plot, that's why you are not able to understand. So this, the first one, the one is um, estimated because these data are very less, so that's why it is looking like this. But this is the thing, this maybe the brown color is the actual data, and these are the estimated data based on that. Or we can see in another way. Okay, this is some arbitrary data, so that's why it is looking like this. So this is the way you can polynomial means the regression for single variable and in multiple variable you can do. These are the things required extensively in the image recognitions and all. So what we will do, we will convert the image in a matrix. It will denote some numbers, then with that numbers we will train the network and find out the similarity. We need to fit it and with this analogy we will recognize the image. So that time these are the things it will be required extensively. Okay, so hope the regression of the regression linear model fitting, higher order model fitting, multiple variable fitting, everything in Matlab, using these few comments you can, if you use your brain, you can execute. Okay, so the assignment of this lecture will be, you can generate a your own excel file with single variable, means single input single output, then using polyfit you can fit the model and show me. And in the second means in the second question of the assignment will be, you can generate a multiple variables, say input is three variable like x1 x2 and x3, and output is y. In such case you can feed the model by your own, you can decide, you can generate your own arbitrary data, and you can submit the assignment in whatever I told. Okay, so thank you so much. Thanks for your patience.